What we want to be able to do is derive a quadratic model given 3 points and be able to use the model. Let's take a look first at this problem here. We want to solve this system of equation. We have 3 variables and 3 equations. We need to find A, B, and C. This is very similar to what we've done before in that we have solved systems of equations, but what we solved before was 2 equations with 2 variables. What would George tell us? George would say, have we ever solved anything similar to it that we could use to solve this? What have we solved with 2 equations and 2 variables? We've done it with substitution or add subtract. Or in other words, the elimination method. What was the purpose of that? To eliminate one of the variables so we could solve for the other. We could use that exact same idea to solve for A, B, and C here, except we're going to have to do it a couple of times. We need to eliminate a variable, but we're going to need to do that one variable twice, and then we can get it down to 2 equations with 2 variables. Let's see how that looks. You can do this a number of different ways. The easiest way would just be to label this equation 1, 2, 3. So if you're comfortable with this, you can do it like this. If not, you can write out the equations. Which variable do we want to get rid of? If we just subtract the equations, we can get rid of the c's. Let's take equation 3 minus equation 2. So 46 minus 12 will give us 34 equals 12a plus 2b, and then the c's go away. If we do that again with equation 2 minus equation 1, we get 8 equals 3a plus b. Now we've gotten it down to 2 equations with 2 variables, and you know how to do that. Let's just multiply the bottom one by -2. We'll leave the top alone. We have 34 equals 12a plus 2b. 16, -16 equals -6a minus 2b. Subtract 18 equals 6a. Divide by 6, a equals 3. Once we have a equals 3, we can find out what b is. So 8 equals 3 times 3 plus b. So 3 times 3 would be 9. Subtract 9 from both sides. b equals -1. Now how do we find c? We need to go back to one of the 3 original equations. Let's use the first one since that's the easiest. 4 equals 3 plus -1 plus c. 3 plus -1 would be 2, and then subtract that from both sides, so we get c equals 2. Now, what is the purpose of this? This is an important step right now. It's hard to see the relationship to what the objective is for today. What I want to do is I want to say what this is. This is the solution to. So here's the actual question. Find a quadratic model given f of 1 equals 4, f of 2 equals 12, and f of 4 equals 46. So to see how this is a solution to that, we need to figure out what is a quadratic model. What's a quadratic equation? A quadratic equation is an equation that is x squared. Let me zoom out a little bit. And let's take a look. We can write a general one and say f of x equals ax squared plus bx plus c. Now, where do we get those equations from? The original 3 from this. If we take a look at that first one, f of 1 equals, remember this is saying x equals 1, so it's a times 1 plus b times 1, or 1 squared on that a part, plus c, and that's going to equal 4. F of 2 is going to be a times 2 squared, or 4, plus b times 2 plus c, and that's going to equal 12. F of 4 is going to equal, and here I've tried to show this in various degrees of showing all the steps, but you can look at it and say, okay, what is 4 squared? 16a, and then 4 times b plus c equals 46. Now, given that, the answer is f of x equals 3, that's what we found for a, 3, not a, 3x squared plus b, b is negative 1, so minus x, and then plus c. All right, let's take a look at kind of applying some of this ideas to a problem. Here we're going to graph the table, which is a number of cable subscribers in the U.S. since 1970. So I've kind of set up the scale for you. You can see the darker lines. I'm trying to think, can we go by 5s going up? It doesn't look so. We need to get all the way up to 44. Looks like we need to go by 2s for each square. So 10, 20, 30. Oh, maybe not even that. How many do I have? Maybe I want to go, I need to get up to at least 44. So perhaps I want to go by, let's see, what kind of numbers do I have here? How about we'll go by 3s. So we'll go 15, 30, 45, and that'll be 60. All right, so let's